xy squared, and y times this gives us plus y cubed. Bringing like terms together, x cubed. How many x squared y's have I got? I've got 2 here, okay? And I've got 1 there, so that gives me plus 3x squared y. How many x y squareds have I got? Well, I've got 1 there, and I've got 2 there, so that's 3xy squared plus y cubed, okay? Which is exactly what the third row gives us in relation to the binomial expansion. Let's have a look at something else. Let's just have a look really quickly. Okay, I'm just conscious of the time here. I don't want this video to go too long. Okay, let's say if we wanted to expand out x plus y, let's say to the power of 6. Okay, bit of work involved in expanding that out, but let's do Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. How many? I need 6, the 6th index row. So this is 0, this is 1, this is 2, 3, this is the 4th. So let's do the 5th. So this is 1. The sum of these is 5. The sum of these is 10. The sum of these is 10. The sum of these is 5. And then finally our 1. So that'd be the 5th one. And then I need the 6th one, which would be 1. The sum of these is 6. The sum of these is 15. The sum of these is 20. The sum of these is 15. The sum of these here is 6, followed by 1. This is my 6th. This is my 6th row. So these are my coefficients for each term. These are the binomial coefficients. So therefore, what I have is that x plus y to the 6 must be equal to, it's equal to 1x to the 6 plus 6x to the 5 times a y, because y to the 1, because both of these must add to give 6, plus 15 x to the 4 this time times y squared. You see, both of them are adding. You see the way I'm decrementing the exponent associated with the x, and I'm incrementing the exponent associated with the y, and they're balancing off that the sum of them is always equal to 6, plus 20, decrement the x down to a 3, increase the y up to a 3, plus 15, decrement the x down to a square, increment the y up to a 4, plus 6, decrement the x down to an x, and the y goes up to a 5. Okay, plus 1 what? Well, the x is going to get decremented from the 1 here down to a 0, which is just 1. So that's going, and the y is going up to y to the 6. So what we end up with is x to the 6 plus 6x to the 5 times y plus 15 x to the 4 times y squared plus 20x cubed times y cubed plus 15x squared times y to the 4 plus 6x times y to the 5 plus y to the 6. Wow, imagine having to multiply this out as x plus y times 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 x plus y. Imagine having to do this multiplication, yeah? It would take it a fair bit of time to do. Okay, so just recall that these coefficients, okay, that these particular coefficients in the binomial expansion are basically just the list of a row within Pascal's triangle, where each row starts counting as 0, 1, 2, 3, 4, 5, 6. Okay, how far down do I go? Well, how big is my exponent that I need to expand? Okay? So let's just recall again what the binomial theorem, binomial expansion actually says to us. It effectively says this is that x plus y to the power of n is simply equal to the sum of, from k is equal to 0 up to n. So we've really got n plus 1 terms. So if we had started at 1 up to n, there'd be n terms. So we really have n plus 1 terms because we're starting counting at 0 up to n of nck times x to the power of n minus k times y to the power of k. Okay? So we're going to just basically do this particular term for each one of the values of k that's going through the iteration. Okay, guys, I hope that this explanation, well, albeit we didn't prove the binomial theorem, okay, rigorously, okay, I hope that this particular explanation was in some way intuitive and really, more importantly, I hope that was helpful for you. And thanks for watching. Once again, this is Jonathan Lambert with Maths and Stats. And if you get a chance, please subscribe. Okay, thank you. Bye bye.